got a few problems up on the board. I want to just practice evaluating some definite integrals using the fundamental theorem of calculus, which says all I have to do is find an antiderivative, evaluate at the endpoints, and subtract. Okay. So I've got 3 problems up here on the board. I'm going to suggest that you pause the video, try to work those through. You're going to have to think back to what we did in 4.9 with finding some antiderivatives. You're going to find yourself an antiderivative, evaluate, and subtract. So go ahead and pause the video. Welcome back. Okay, here this is a power of x. I'm just going to use the power rule. That's going to be x cubed over 3. Remember, when we're finding an antiderivative, we raise the power by 1 and then divide by the new power. And if I'm ever not sure, generally speaking, taking the derivative is easier than taking an antiderivative. I can just take the derivative really quickly and confirm that I do get x squared. So there's my antiderivative. I need to evaluate it between 3 and 1. So that's going to be 27 thirds minus 1 third, which is going to give me 26 thirds. Excellent. So here, I'm integrating secant squared. I recognize that that's the derivative of tangent. So I'm going to say an antiderivative would be tangent of x, and I just need to evaluate that at pi over 4 and 0 and then subtract. Now it is important that secant squared and tangent are defined on this entire interval. I couldn't go from 0 to 2 pi because secant squared would have asymptotes in there. So this function does need to be continuous on the interval determined by those endpoints. But it is. So now I get tangent of pi over 4 minus tangent of 0, which is 1 minus 0, which is 1. Excellent. For this one, that's a power of x. That's x to the negative 1. But remember, negative 1 was the one power for which we couldn't use the power rule. Because if I raise negative 1 by 1, it gives me 0, and I can't have that in the denominator. So this is the one function where I think it's easier to keep it written as just the reciprocal. An antiderivative of 1 over x is the natural log of the absolute value of x. I need to evaluate that between negative 1 and negative 2. Notice, if you forget the absolute value here, you're in trouble because you can't plug negative numbers into the natural log function. But if I'm taking their absolute value first, now this is the natural log of the absolute value of negative 1 minus the natural log of the absolute value of negative 2. That's just the natural log of 1 minus the natural log of 2. Natural log of 1, I know, is 0. That, remember, is the x value of the x-intercept of the log graph. Natural log of 2 doesn't simplify, so I'm getting negative natural log of 2. If you prefer, you can use rules of logs. That's the same as the natural log of 1/2, because I can bring that negative sign up and say it's 2 to the negative 1. Either of those is a perfectly acceptable answer. Excellent.